Assalamu alaikum. This is Shad al-Qassas, the physics teacher, Sharjah American International School. And today, inshallah, with my 11 students, we're going to prove that Archimedes' principle can actually measure the FB or the buoyant force. And we can use also another rule, which is the difference between the real weight and the apparent weight in order to measure the buoyant force. So this is an object. And in order to get the real weight of the object, I will use the spring scale. So by hanging the object in the spring scale, like that, and reading the value, we can get its real weight. So I'm going to choose another object here in order to have this value. So if we measure this, the weight of this object, so it reads 1.5 newtons. This is the real weight of the object. If I drop the object in the water here, in this fluid, so this is basically a filled cup of fluid. So once I drop the object here, I will find out that the weight of the object will be less, because this is what we call the apparent weight, and the apparent weight is the weight of the object inside the fluid. The difference between the real weight and the apparent weight will be buoyant force. So basically, it will read here about 1 Newton. So 1.5, which is the real weight, minus the apparent weight, minus 1, will be 0.5. Which means that the buoyant force, or the upward force that is carrying the object upward in the fluid, is exactly 0.5 newtons. Archimedes told us that there is another principle, or there is another rule I can use in order to exactly identify how much is the buoyant force, which is, when I put the object in the water, it displaced some fluid here, some water here. This is the displaced fluid. So this water came from the displaced volume of the object. So basically, the volume of the object is exactly equal to the volume of the displaced fluid. Archimedes told us that if we measured the weight of the displaced fluid, so by measuring the weight, we can calculate the mass, and then by doing your own calculations, you will find out that the weight of the displaced water will be exactly equal to the buoyant force that you have calculated by the difference between the Fg and the F apparent. So basically, you can calculate the buoyant force using two ways. The first way is to get the difference between the real weight and the apparent weight. It will give you buoyant force upward. Or you can just displace some water here by the object, and then you can have the weight of the displaced fluid, which will be exactly equal to buoyant force. Thank you very much.